Hi everyone, good afternoon. It's my pleasure to moderate today's panel discussion on vehicle intelligence and how hardware and software are evolving to meet these increasing requirements. So let me first, start off by quickly introducing, myself and then the panelists, so that you know us better and you know a bit more about our backgrounds. I'd like, first for each of the panelists to talk about your background and your current role, and also then to talk about how has AI impacted you in a personal manner, something that has changed how you do things in your day to day. Let me give a quick example for myself. So my name is Amod, and I'm with Harman International. I work in the intelligent cockpit domain, working on driver and occupant monitoring solutions. One way AI has played a big role in my personal life is I'm an avid birding photographer. I really like to take pictures of birds, and I'd never know what bird I was shooting. Now there's a very nice app called Merlin. I just upload the photo and it tells me which bird it is, and that's really made my experience as a birder significantly better. So, Angelin, yeah, we have yeah introduction.
Hello. Hi, this is Angelin Mary from Daimler Truck Innovation Center, India. I have been in the industry 28 plus years across various roles in tier ones and then now with the commercial vehicle OEM. This is a good opportunity to be here and share my thoughts and also with the lovely panel here and to know all of them. Coming to the AI, so how, I was trying to utilize the co-pilot recently. It's really, I am a little bit challenged to read all the emails these days, and I want to read at least my boss's emails, quickly. And I was using this Copilot recently. Okay, can you please summarize the last 48 hours, what my boss said to me? So it was nicely, prioritizing and giving, oh, this is what he asked for you, and you shared this. And, in the car while, in the Bangalore traffic, it was a good experience to, quickly go through that. So, yeah, that was
Wonderful.
surprising.
Yeah,
Thank you.
great. Ajay, the toggle switch.
Yeah. Hi. Good afternoon, everybody. Myself, Ajay Mittal, part of the Volvo Eicher Commercial Vehicle Group. Uh, Almost more than 6 years with the organization, handling all connected and digital area for my organization. Carrying about 20 plus experience in analytics, majorly. Now looking after IoT and connected as well. And on a personal note, my example of using analytics is what mobile phones nowadays started giving one insight that how much is your phone usage has been today versus last week and all. So it is just keeping me informed that how much is my adoption of phone has happened, a screen time. So it is making me think that I should be focused more on other things than only spending time on screen. So that is what the example I'll quote and taking inspiration from it to improve my, rather than going for a digital detoxification, having a control on it. So that's what my take on it.
Thank you, Ajay. Yeah, Dhruba.
Hi, my name is Dhruba Sharma from KPIT Technologies. Audio is okay?
Yeah.
Okay. I've been around in the automotive area now about 27 years, so looks like it's been a long time. And like in the SDV presentation, and I was telling Amod that SDV probably should be on the Limca Book of Records now, the most used and most written word, which has not changed in like 3 years at least. The same word is being used. Personally, I think I would say I started back in the years with a lot of powertrain work, but then moved into infotainment and in spite of some of the changes, mostly been around in the connected space, cockpit and the cloud area. At KPIT now about 11 years, I take care of our global business for connectivity and body, like I think I mentioned. I think talking of AI, no, I had an interesting experience with respect to my daughter. while we all use these applications, but then no, she has done her graduation and she has a startup now, and she wanted some funding. So I gave her some gyan, and then I said, I need a business case for me to fund you, so that I can track. And I told her to catch up on certain things and prepare a business case. And in 2 days, she actually sent me a business case. Okay, and then I realized after checking around that she used a lot of AI tools as they are around to build a nice thing, right? So I think the point here is AI has become built into our way of life, and probably, and I was talking to some of my colleagues in Pune yesterday, coincidentally. We are probably with AI similar to what we were with internet about 25 years back. And then it just becomes part of your life. You can't live without it. And AI is going to be like that. Whether it overtakes us is something scary, but we'll see as time goes.
Yeah.
So nice to be here.
Okay, great. That's great. So we have such an eminent panel with so much of background and experience. So I think one of the ways we can now start getting into the topic of the panel itself is to talk a little bit about what was the first AI-related application that you worked on, and how did you do that particular work versus how has it changed to the projects today? Maybe we'll start with Ajay first.
Thanks. So for me, my first experience on AI, I'll take a step back in that way, on analytics, to be honest. So in my previous engagement, we were working on analyzing a lot of data to figure out a pattern of telecom consumers. How is their recharge patterns, their billing patterns, influences their lifestyle. Now that is what we were analyzing, and then we figured out that interesting things. One of the very simple and interesting finding that came out was people who has a potential, or rather a billing pattern of spending more than 1,000 rupee, more inclined towards opting for American Express credit card. Now that was a very lifestyle type of an insight we got, and we contacted American Express Bank about it, and then they found it, it's a relevant insight, and they used it to take a campaign around it. And then they saw that the conversion is high. So that is where we saw that, okay, if we are able to make insights which are more towards lifestyle pattern and profiling, then there is a potential of using it for that purpose. Nowadays, we see it has changed a lot of dimensions and magnitude of it. So from there, now the journey has gone towards how we can leverage that in our automotive sector. Now I'm part of the automotive organization. Therein, we are talking about how data coming out from vehicle or operations of vehicle which is running on the field, how it can be used to improve the customer experience in terms of getting maximum uptime from the vehicle, getting maximum operations from it, how technicians at workshops can be made more productive by giving them relevant insights, how vehicle operation by a driver or running by a driver can be improved. So that is the area that we are looking at, and I'm sure my co-panelists will talk more about how vehicle architecture is changing and how AI is getting into the vehicle more and more. So,
maybe with respect to starting off with AI, we saw at KPIT a lot of means the data analytics part, of course, in terms of the commercial vehicles uptime and all of that. I think Ajay, you talked. But apart from that, what we saw is a lot of pressure on the development cycle itself, right? So that is where I think a lot of our effort is going, and importantly, around the industry, a lot of effort is going in the AI space. How do you look at the development cycle in terms of bringing AI into it, and more importantly, generative AI? I think AI has machine language to AI. To now, I think it's more of Gen AI and not AI per se. It's more Gen AI with all the tools. So more and more work will happen in making our workflows optimized to create more productivity. Because the industry today, due to the various situations, you can see that in Europe, you can see that in North America from the automotive context. I think that this year is a challenging year, and probably the year after will also be challenging. So productivity is a huge area. How do you do more from an engineering perspective with less, or more with same at least, right? So that will drive a lot of the generative AI work. I know for sure that pretty much everyone around in the industry is looking at it. What, however, is important is how do you tie all these pieces of work into workbenches that can be repeatedly or repetitively used across different types of programs, and thereby make it really quantifiable, right? We should be able to tell that this kind of a development stage in a product development, and not limited to software. We always talks more about software, but any part of a product development can be optimized at least by this much, right? And then you quantify that into your costing process, your whole bill of materials, everything. I think that's where we are seeing doing a lot of work, and I think that's also an area where many of the industry people are spending time.
Okay. Yeah. Yeah. Angelin?
Yeah. So to answer your question on what is the oldest or the earliest application of AI that I used, but I took an elective of artificial intelligence without knowing the importance in 25 years or so, how it's going to be. And of course studied Lisp programming and other things, but we developed a project also, a simple project on how do you diagnose a patient. So if you have a headache, then what? Do you have a sore throat, then what? I mean, we didn't realize that it's going to be in this significant or a massive level in 25 years. So that's the first journey of artificial intelligence. But now being in the commercial vehicle OEM, like a largest commercial vehicle OEM, like Daimler truck, so we are focusing on predictive maintenance of our trucks, because the idle time is not good for the fleet owners of the truck. So we need to keep the uptime of the vehicle. So the predictive maintenance help a long way for them to maintain the overall total cost of ownership for the fleet owners or the truck owners basically. So and then the remote diagnosis, remote fixing, or all those kind of things using the data collected remotely from the vehicle through this connected trucks. And another important thing is the route optimization. This is mainly we keep doing it and improvising the algorithms and improving the efficiency. In the electric vehicles, especially in the long haul heavy duty trucks. So it's very important for them to go with an efficient energy consumption in the battery vehicle. So this is where the route optimization comes very, very handy, on which is the shortest route or where the traffic congestion is less. And also about the charging infrastructure. So some are expensive and some are not having the ability to charge a truck in a slowest possible time. So in fact also suggesting which is an optimum optimized charging infra available in that route and so on. So yeah, so we have come a long way in AI, I would say. Yeah.
Okay.
Thanks.
Yeah. That's great. I think we got some wonderful perspectives here. So maybe Dhruva, a question for you to kickstart. So when we now start, you already heard quite a few use cases here, right? If you were to now start looking at the vehicle as a series of domains, then how do you see the evolution and the increasing levels of intelligence that go into the vehicle itself?
Yeah.
To the fact that we can now start calling the vehicle intelligent and so on. So how is it evolving across domains? What are some trends that you've seen?
Right. I think that's very interesting, and we can probably correlate it to a little bit in terms of how it has changed, right? I mean, if you look back in the 50s, 60s is when the intelligence in the car was to the extent of some kind of cruise control. I mean, it's the 60s, right? And then in the 80s is when this automatic cruise control came. And that was the next level of intelligence, which in some way used data. And then in 10 years, the sensors became. the purpose of data there was more for control. And the sensors became more of the video sensors, the lidars, and radars, all of that came, right? So that was like, 10 years back, that is where a lot of focus went. And then in the last few years, I think the focus on data has moved from control stays, so whatever was there stays, but has moved now more into personalization and data monetization actually, right? So that's the latest focus and leverage of data. So that has, like Angelin mentioned, Ajay mentioned, that then can be boiled down into the domains. Because, so everything is at the end of the day driven by business sense. So uptime and all the monetization topics is what is driving the all the analytics is basically to create more uptime in some way, right? Or all the diagnostics is also targeted to the same purpose. So that whole area from a powertrain perspective is a large area, right? Even from a body perspective, it's a large area. Anywhere you have parts functioning, it's a large area. And that if you couple together with artificial reality, so not just the intelligence part, the AR and the VR, then becomes a full cycle, right? Intelligent goggles and intelligent, all the reality. So you can enable from diagnostics to actual fixing of things, right? So that's a large application. Then if I come to the pure the cockpit related or infotainment kind of use cases, there's a lot of more recent things like even gaming. Gaming means for a lot of us in India, probably it's not in the midst. We are used to it on the phone, but gaming is not on the vehicle. There are now companies who do gaming software for automotive. So which are lightweight, which do not actually need to be massively hosted onto the device. It's just a client which needs to be hosted on the cockpit of the car. Extensively in China, but also parts of Europe and I would say Europe, not as much in US. So those again create new opportunities because the data tied to the patterns around it. Ajay talked about the pattern, right? So it means unless you create the pattern, you can't even realize that certain things could happen. So what we saw, for example, is that when you use, and when do you play the games? You play the games usually when you are at a charging station because you can't drive and play. And then can you use that to connect that person to certain parking apps, certain apps that connect you to a coffee day or a Starbucks, incentivize the person to actually go to a particular Starbucks. So all of these are businesses which then tie up. I think when we talk about it, implementation seems simple, but when you actually make it in a complete picture, it's a lot of things that need to be done, which of course then boils down to the architecture of things which we can talk later. So this is how we see it's across the domains, a lot of things happening, either driven by the cost angle, all the uptimes, and so the commercial vehicle industry I think is driven by the cost angle. And the passenger vehicle industry is driven more by can we do something more for monetization? Because, which is the basis of SDV, the presentation throughout the day. SDV, the need for SDV was monetization. How can I keep upgrading my car over 10, 15 years so that I can put in new things? And why do I put new things? To create more monetization out of the car. So I would stop at that.
Okay, yeah, no, wonderful. I think, you basically walk through the journey of, how AI has been, evolving, right? Starting from being an automation tool and, primarily for safety to then becoming more of a convenience and, making life easier in the car to now becoming a complete entertainment and an intelligent assistant and really, transforming that, right? Would either of you have anything to add to this or?
Yeah, sure. So my addition to that will be when we look at a vehicle, we should look at the life cycle of the vehicle from manufacturing to going to the dealership to the customer and then the maximum time which is spent by the customer on the vehicle during the life cycle. Now, when we look at all those things, we come to one important aspect, that is persona. Who is touching the vehicle? Now, that is where it gives an opportunity for us to look at what type of analytical or technology-oriented solutions which can be brought on to improve the experience of that persona, as well as then the vehicle which is actually traversing that journey. Now, manufacturing, it's all about, we can have automated manufacturing, Industry 4.0, now moving towards 5.0. All those aspects we can talk about, improving vehicle design, leveraging analytics, or AI we are talking about. The moment it goes to dealer, how we can improve the performance of the dealer, the technicians, the sales agent, again, enable a lot of AI or Gen AI enabled technology tools. Then within the vehicle, which improves its operation as well as improve the experience of the driver. And ultimately, vehicle owner gets the maximum out of it because he is running the vehicle for a business. So how all those personas can be given an experience which is enabled through technology gives a lot of ability for us to think and drive those solutions. In vehicle digitalization, which is again talking about SDV, but let's move a couple of steps back. What is happening today? What will happen tomorrow? And then down the years, the DCU architecture or infotainments or integrated or connected clusters we can talk about. ADAS or DSMS we can talk about. All those are innovations which are coming, or technology experiences which are coming, are enabling the personas to experience in a better way. So that is what my addition to that will be.
Okay, all right.
Yeah, so maybe I think they have covered many other areas. So I thought a little bit on the safety side, right? So when we talk about ADAS in trucks, for example, in commercial vehicles, so we are still in the level 2, and I don't think we will get into the level 3 truck being very sensitive, and in the highway directly we are working on the level 4. But in the level 2, the currently, so either it is a Mercedes-Benz trucks or any other US market Freightliner or Western Star trucks. So we have this, of course, comfort features as well as safety features under ADAS. So one is the connected traffic warning, which is the recent one that I wanted to talk about. The vehicles, right, talk to each other and share on, okay, on this highway there is a road closure, or in this there is a heavy traffic or traffic congestion, or there is a tunnel which a big vehicle cannot pass through. So these kind of information are available through cloud to the truck drivers. So based on that, the routes are also suggested. Okay, now you take this route versus this route, right? So everything is monitored by the fleet owners or the fleet manager remotely as well. And this is definitely helpful for the truck drivers as well as fleet owners. And this is not just only our vehicles or our trucks are connected and talking to each other. There are multiple partnerships also evolving in this area, right? So we also use some third-party, services with Bosch in this case, but there could be many to also stream such information through cloud to our vehicles. So this kind of an advanced or technologies for making the vehicle more and more intelligent, also evolving the industry into multiple partnerships. So this is another important thing, I think. I am always, amazed of. Yeah, thanks.
Yeah, that's great. Yeah. So Angelin, maybe a question, to follow up on that. Obviously, as we, see AI pervading all these different domains in the vehicle and so many much more use cases and increased complexity, you can't achieve this for free with the same hardware and, same architecture that you had in previous generations. So, could you then, shed some light on what are some trends that are happening on the hardware side and more broadly into the vehicle architecture itself? Obviously, SDV is a big part of this, but speaking about it from, again, AI workloads coming into this.
Yeah, definitely. As you all know, there are many ECUs. I think in the previous one of them also presented ECUs in the car, but in the truck, maybe 60, 70, ECUs fully loaded with electronics and intelligence. From the independent distributed ECUs with lot of wiring harness heavily loaded in the vehicle, we have come a long way into domain controllers, right? So your infotainment or navigation, and then your body control, yeah, vehicle control and upfit we call it. And then we have our ADAS or safety related, yeah, so and so on. From the domain controllers, now we are slowly moving into the SDV with the high compute, right? So HPCs, basically high processing computers. This is not just to have the high performance or a high bandwidth and video streaming and to be connected and all that, but it's also to minimize our dependency on our tier 1 suppliers. So today we have multiple ECUs or multiple domain ECUs or domain controllers, but we are heavily depending on our tier 1 suppliers because each ECU is talking different languages. I mean, what I meant is the hardware is different because they have their own product roadmap, their own hardware roadmap, and we have to just adapt it, right? So, and multiple operating systems, multiple, AUTOSAR from different AUTOSAR vendors. And so there is even different versions of AUTOSAR within the ECUs in the same vehicle platform. So this is also leading to installation or overall vehicle configuration challenges for us. And in order to minimize all these, we are moving towards this SDVs and getting into cross-domain HPCs. So this is also another one, what I was speaking about, the partnership. This is also leading to even competitors' partnership, right? Because commercial vehicles will not have a huge volume like a passenger car. So we definitely need a volume partner. And recently Daimler Truck, agreed upon a partnership with Volvo and two giants in the commercial vehicle industry. And we are starting a joint venture in order to develop an SDV platform for us. So the differentiating software will be with us within Daimler Truck on the top layer, but the hardware platform and also an operating system specifically for these OEMs, our joint venture will develop. So we are in the journey of moving into this hardware platforms which could host even computer vision and artificial or AI accelerators and or AI inferences capabilities which can host your infotainment, your navigation, your connectivity, your ADAS, your AD also within the same HPC. So this is the journey we have just started and looking forward, to be part of this journey. Yeah.
Okay. So a lot of these multiple domain ECUs kind of get mashed into one single powerful ECU, and then in software you try to separate each of the domains virtually and manage there. Okay. Yes. Ajay, Dhruva, do you want to add anything here?
So I think she talked about the vehicle architecture from the perspective how it is getting changed from multiple ECUs to domain controller to SDV. Within that, there are two aspects which are getting added. I'm sure she would have spoken about it. The one is how the communication architecture inside the vehicle is changing. Earlier or currently also, it's primarily based on CAN. I think previous speaker was talking about it. Now that CAN architecture is now moving towards the Ethernet one. So that is also very important to make a high compute processing inside the vehicle to be done, call it like within the vehicle itself. And for that, the connectivity inside the vehicle has to be on a high speed, and then that Ethernet architecture is coming on the way. Second part is the role of the cloud service providers is also increasing. Now, a lot more accelerators from the cloud side are coming so that the edge part of the cloud is contributing more in the vehicle experience. So a lot of features on the infotainment, subscription of those features, activation, deactivation, all those things are possible when we have cloud connectivity and cloud architecture enabling that. So these two are the additions which are happening as we are looking at this architecture. It is moving. Lot more things when we look at inside the vehicle. For example, we talk about DSMS, one simple use case. Lot of things are done inside the vehicle because driver is there. But the insights of it, which are coming out of the driver experience, the driver behavior, which is used by the owner to make vehicle operation better, they need that insights to be available in an app or a platform. Now that can happen when there's a cloud connectivity and the owner sees that insights, so that he can again call his driver, teach, and make experience better. So architecture-wise, the journey is moving towards from DCU to SDV. Vehicle architecture inside communication architecture is changing, and cloud providers are becoming more and more integrated for this vehicle journey. So that is what I see that is adding to what she just said.
I wanted to bring out 2 points. One is pretty closely related to what Ajay mentioned, which is in terms of architecture. We are talking about data. Pretty much everything is around data. And I think the previous speakers, right, the esteemed expert from cybersecurity, as he said, the architecture needs to be built in. You cannot create it when the need for the service occurs, right? It's not going to be by default available. So from our perspective, because we end up working with so many OEMs, based on all the experiences, what we have come out with is we call it as a data first architecture. Because you need to think of data, what do you need, when do you need, where will you get it? Because exactly the point, what do you do on the edge, what do you do on the cloud? And within the edge also, how much do you pass up, right? Because everything is cost. So we call it as data first. Tied to that is your Ethernet, because data has to be available. There is one more thing which is called the service-oriented architecture, because that is again fundamental to be able to upgrade your software in pieces instead of updating gigabits of software. But then again, a lot of times, I think as engineers, we are excited to do everything in the technical way. So we go all out to make everything service oriented. So you just create layers over layers sometimes. So our principle is that we need to have a balance between what we convert to service oriented architecture or SOA and what we don't. Keep it as signal oriented, because you are not going to go to that level of upgrade for that particular thing. So that's again a part of architecture. So this I wanted to highlight from the data side. The other part is from the hardware architecture side, right? I think a lot of the existing chip makers or SoC makers are coming up with SoCs that are no longer only capable of doing, say, high performance infotainment. They are also capable of doing ADAS together with infotainment, right? I'm not going to use specific SoC, vendor names, but that's kind of a trend. How do you club things together? And a lot of the basic hardware design, instead of being monolithic, is now built on multiple NPU processing units, multiple chiplets. That one base concept in terms of hardware is slowly going away. I mean, it will take time to completely go away, but the designs itself are done in terms of chiplets. So just like software has become scalable, hardware design at a SoC level has started becoming scalable. I think all of this is happening, which is increasing the power on the edge, because the cloud already has multiplied, but the power on the edge is also multiplying very fast, not in 2 years, 3 years, but like every year. And these things are going to increase the momentum of any kind of AI. So these two.
Yeah, excellent points here. So, Dhruba, just to follow up, I think you talked a lot about how data is critical, and whether you process it directly at the sensor level, or you bubble it up to the controller, or do you send it to the cloud and so on.
Yeah.
This then raises that question, especially if you are looking at things like personalization and personal data, as to how do you manage the trade-off between the feature versus the privacy and the security aspects. What are some trends that you're seeing towards this direction? And maybe after you, Angelin can answer.
Very interesting question. I think we have lived through as an industry for a long time, strongly believing that personal data is personal data and nothing can be done about it. I think Europe drove a lot of it in terms of nothing can be shared. China is on the other extreme. There is not a significant push or mandate to really not have something shared. So as a result, a lot of additional use cases or experiences are available on the cockpit or inside the vehicle in a car in China. And while these are not, I would say, features of a vehicle, but those are very nice add-ons and that create, just like mobile phones, it's phone on a wheel. That experience is now completely there in China. So I think my point therefore is there will be this I would say fear, and therefore the need for OEMs to architecturally have the ability to prevent certain parts of the data to be not available or basically control so that you can't, somebody can't just have that. I think that will be there. But Angelin talked about the partnership topic. The moment you talk of partnership, it also means sharing of data, because the data will earlier, before the session, Ajay, we were talking and the point came up as most of the OEMs will not be hosting data themselves, right? Because that's not their business. The data will still be hosted on Azure or Amazon or a Google Cloud. And you can only be so much paranoid about hosting it somewhere else and not in your campus, right? You have to give up at some point. So all of these will balance out the whole privacy topic beyond a point is, I would say, my personal opinion, not KPIT opinion.
Okay. Yeah, Angelin.
Yeah, I can add a few more points. I think Dhruba covered it very broadly. Especially in the Europe, data privacy is very, very critical, and they are sensitive to taking pictures, right? For example, in the North America market, we could bring in a driver monitoring system. So it monitors the system and then alerts the driver when there is a drowsiness or there is not enough attention or there is a distraction and so on. But for Europe, it is coming soon as a regulatory, but little later than the North American market. So we are working on that to bring it in probably 26 on advanced driver drowsiness and attention through inward facing, camera. Oh, by the way, for India commercial vehicles also, it's getting into the regulatory for ADDW in 26 April, basically. Suddenly they pulled it ahead by, I think, 2 years, which we were not expecting. So we are all like, running towards making it happen. So coming to the data privacy, it is more of OEM's responsibility, right? Because the vehicles keep collecting the data through sensors. It could be cameras or, various things for ADAS or for, advanced autonomous drive. So it is not just from the passengers or the driver inside the vehicle, but also the surroundings, right? So there is a lot of data getting collected, but how do we use it responsibly, only for the safety or for the comfort, of the passengers, or safety of even the vulnerable road users. So that is the ethics that the OEMs will have to sign up for, and they are definitely doing it. I would say there is one more thing also we do in Daimler Truck is data anonymization. There are the pseudo anonymization is also there as a concept, but we do this data anonymization as an algorithm so that you are using the data for your safety feature, but not for taking any personal data, and so on. So the ethics and the data privacy go hand in hand.
Yeah. Okay. No, I think these are some great points that came up here. We do have a couple of minutes here, so would we have time for a couple of audience questions?
So my question would be have you already thought about introducing
Migration. To specific answer to your point, the answer is yes. DSMS is a simple example of it. How we are converting an algorithm into an edge which can run inside the vehicle without waiting for a cloud or somebody to play a role in running and then giving an output. So now it calls for a vehicle device or an HPC unit or a processing unit to be powerful enough. Again, not to mean that it needs high processing, because that's how edge works, that it can be a lightweight, specific event can be detected, and accuracy depends on the size of the vehicle, the location of the unit which is fitted, where it is fitted, coverage it is getting, all those things, and both sides, the DSMS which is inside the vehicle and the outward side which are coming. So Angelina talked about the compliance which is coming on the way. I think government have just announced, right? They have preponed it by a couple of years. And it's an opportunity and a challenge both to meet that. So we are all are working towards it, to how we can quickly enable it, because vehicles, registration, everything, homologation is all going to be dependent upon that. And second, it also gives a lot of opportunity for bringing safety aspect into vehicle operation. That is how we have to see it.
I can add a little bit more. Of course, AI ML models are being used not just to replace the sensor, but currently being used in order to bring our algorithms more efficiency compared to our physics-based models. For example, in route optimization or predictive maintenance and so on. But replacing the sensor, working on it, right? So as part of the SDV, for example, with the powerful HPCs and where the SOCs from some of the semiconductor giants are coming up with computer vision algorithm. So we have a plan, even in the some of the AD kits, it's already being there, and maybe 27 or in the second half of this decade, it will come into life, on the roads. Replacing the multi-purpose camera, for example. It could be a forward-facing camera, or in the side mirror truck being very, very big. So we have this active side guard assist in both the sides with mirror cams and so on. So it will replace some of these cameras, for example, the computer vision, SOCs with the computer vision abilities and AI accelerators. So this could be one example that I could think of.
Okay, yeah. So we're at the end of our time slot. So if you have any further questions, I think you can reach out to all of us during the breaks. So once again, I thank all of you for excellent set of points. I think the key takeaway for me, one of that I think that Dhruva you just mentioned, was how can we do more with either the same or less. I think I'd take that away as like a key trend that's driving all of us forward with this new intelligent era. Thank you, everyone.